Find the y-intercept, if any, x-intercepts, if any, vertical asymptotes, if any, including the asymptotic behavior on each side, and holes, if any, for f of x equals 2x squared minus 3x minus 2 divided by x squared minus 4x minus 12. The first thing to find is the y-intercept, where the function crosses the y-axis. Defined by x equals 0, and the corresponding y-coordinate can be found by plugging the 0 in for x into the function, which gives 2 times 0 squared minus 3 times 0 minus 2 divided by 0 squared minus 4 times 0 minus 12. 2 times 0 squared is 0, minus 3 times 0 is minus 0, minus 2, divided by 0 squared is 0, minus 4 times 0 is minus 0, and then minus 12. 0 minus 0 minus 2 is a negative 2. 0 minus 0 minus 12 is a negative 12. The negatives can cancel, and the 2 and 12 can reduce by a 2, giving 1 over 6. So the x-coordinate of 0 has a corresponding y-coordinate of 1/6. There's the y-intercept. The remaining parts are found by taking the function, which is f of x equals to 2x squared minus 3x minus 2 divided by x squared minus 4x minus 12, and fully factoring it. In the numerator, that is a trinomial quadratic, so it will trinomial factor. Since it's 2x squared, it will be a 2x and an x. And we need two numbers to multiply to be a negative 2, and add to be a negative 3 after one of them is multiplied by 2. Factors of 2 are 2 and 1. It looks like we may need to put the 2 here and the 1 here so that we have a 4x and a 1x to give a negative 3x. We need the 4 to be a negative and the 1 to be a positive. So we will need a negative here and a positive here. In the denominator, also a trinomial quadratic. It's just x squared, so it will just be x and x. We need two numbers to multiply to be a negative 12 and add to be a negative 4. A negative 6 and a positive 2. Take care of that. We now want to cancel any factors that are common in the numerator and denominator. We don't have any common factors, so nothing will cancel. The x-intercepts, where the function crosses the x-axis, defined by y equals 0, can be found by taking the numerator that's left over in the fully factored canceled version of the function and setting it equal to 0. That will give 2x plus 1 equals 0, and x minus 2 equals 0. 2x plus 1 can be solved by subtracting 1 from both sides. Divide both sides by a 2, and we get the x-coordinate of negative 1/2. This corresponds to a y-coordinate of 0 for the x-intercept, negative 1/2, 0. Solving the x minus 2, add 2 to both sides, x equals to 2. So this x-coordinate of 2 also corresponds to a y-coordinate of 0 for an x-intercept, and there are the two x-intercepts. The vertical asymptotes are found by taking the denominator that's left over after factoring and fully canceling and setting it equal to 0 and solving for all x's that make that 0. That will give x equals 6 and x equals to negative 2. We now want to analyze the asymptotic behavior on each side of these. Starting with the x equals 6, we will look at the left-sided limit of the fully factored canceled version of the function. And the right-sided limit of 6, again of the fully factored and canceled version of the function. Let's start with the left-sided limit. We want to analyze what happens with the factor in the denominator that is making 0. As x approaches 6, that's the x minus 6. And x is approaching 6 from the left side here. The left side of 6 is less positive than 6, like 5.99. If that were plugged into x in the x minus 6, 5.99 minus 6 would be a negative number. It will approach to 0, but it will remain negative. So x minus 6 can be replaced with a negative 0. A 6 then can be plugged in for all remaining x's. So 2 times 6 plus 1 times 6 minus 2 divided by x minus 6, which will be a negative 0, and 6 plus 2. 2 times 6 is 12 plus 1 is 13. 6 minus 2 is a 4, divided by a negative 0 times 6 plus 2 is an 8. The 4 and the 8 can factor down by a factor of 4, leaving a 1 and a 2. 13 times 1 is a 13. A negative 0 times a 2 is a negative, and 0 times 2 is a 0. 13 in the numerator is a positive. Positive over negative is negative. Non-zero over 0 is infinity for a limit. And now we will analyze the right side of the limit, again focusing on the factor that's making 0 in the denominator. The right side of 6 is more positive than 6, like 6.01 when plugged in for x. 6.01 minus 6 is a positive number. It will approach to 0, so we can replace it with a positive 0. 6 can then be plugged in to all remaining x's. Two times 6 plus 1 is a 13. 6 minus 2 is a 4 over a positive 0 times 6 plus 2, which is an 8. The 4 and the 8 can reduce by a factor of 4, leaving a 1 and a 2. 13 times 1 is 13. A positive 0 times a 2 will be a positive 0 times 2 is 0. 13 in the numerator is positive. Positive over positive is positive. Non-zero over 0 is an infinity. And there's the asymptotic behavior on each side of the x equals 6 vertical asymptote. We now can work out the asymptotic behavior around the x equals negative 2 vertical asymptote by analyzing the left-sided and right-sided limits. Always working on the fully factored canceled version of the function. Let's start with the left-sided limit. The factor that's making 0 in the denominator here is x plus 2, as x approaches negative 2. It's approaching negative 2 from the left side, which means it's more negative than negative 2, like negative 2.01. If that were to plug into x for the x plus 2 factor, negative 2.01 plus 2 is a negative number. But it's approaching 0, so x plus 2 can be replaced with a negative 0, and negative 2 can plug into all remaining x's. That will give 2 times a negative 2 plus 1 times a negative 2 minus 2 over a negative 2 minus 6, and x plus 2 will be replaced with a negative 0. 2 times negative 2 is negative 4 plus 1 is a negative 3. Negative 2 minus 2 is a negative 4. minus 2 minus 6 is a negative 8. And then times a negative 0. Negative 3 times negative 4 is a positive 12. Negative 8 times a negative 0 is a positive, and 8 times 0 is a 0. The 12 in the numerator is positive. Positive over positive is positive. Non-zero over 0 is an infinity. Can analyze the right side limit in a similar fashion, but it's the right side of negative 2, which is less negative than negative 2. Like negative 1.99, if plugged into the factor that's making 0 in the denominator, negative 1.99 plus 2 will be a positive number, though it will approach to 0, so we can replace x plus 2 with a positive 0. And then the negative 2 can be plugged in for all remaining x's, giving 2 times negative 2 plus 1 times negative 2 minus 2 divided by negative 2 minus 6 and a positive 0 for the x plus 2 factor. 2 times negative 2 is negative 4 plus 1, which will give a negative 3. Negative 2 minus 2 is a negative 4. Minus 2 minus 6 is a negative 8. Times the positive 0. A negative 3 times a negative 4 is a positive 12. Negative 8 times a positive 0 will be a negative, and 8 times 0 is 0. 12 in the numerator is positive. Positive over negative is negative. Non-zero over 0 is an infinity. And there's the asymptotic behavior on both sides of the x equals negative 2 vertical asymptote. The last thing to determine are any holes in the graph, and the holes occur for all of those factors in the factored version of the function that were able to fully cancel with the corresponding factors in the denominator. But we had no factors cancel at all. Therefore, there are none.